Good afternoon. Is my voice okay, Caroline?
Perfect.
Perfect. Good. Good afternoon. I thank you for the invitation to speak in this forum. Now, today I want to share a piece of development in NUS on the PhD program in Operation Research and Analytics. So I want to start with a personal story. So I want to start with my experience in NUS. So this, I think 30 years ago, I was exactly at your position. Just graduated from NUS. I did my undergrad in the Department of Mathematics 30 years ago, staring into the future, thinking of what PhD program to join. Now I show you a picture of a group of young tutors who are then thinking of doing a PhD in different disciplines. Now, I must first caution that a career in academia is not for everyone. So if you want to do a PhD, you have to carefully evaluate your decision into going to a program, because not everyone will find the experience enjoyable. But for me, I personally, I plunged into this career. And one of the key reasons for doing so is because I have fond memories of my days in NUS and my decision to do a PhD and then subsequently to come back to NUS to contribute is actually spurred by my fond memories of my experience in NUS. And I hope when you join NUS in any PhD program, I hope you also have the same fond experience that I have gone through 30 years ago. So I joined NUS, the math department, arguably the best time. So I took classes from combinatorial theory from Teh Hun Heng, graph theory from Koh Kim Ming, probability theory by Louis Chen, and then algebra by Chung. After 30 years, I can still vividly remember my time in the classrooms. So these professors are by now legend in NUS, but when I joined them, they were young, maybe not so young scholars, but actively engaged in research and teaching. And the reason, I guess I'm talking to the young students today in part because I hope to influence your decision in this process, to touch your life, and also hoping that you can join the PhD program in the institute and develop joint memories together. Now, at this point in time, when you are picking a PhD programs, I guess these are some of the pertinent questions that you have to ask yourself. Which school to go to, what courses to take, and which research program to participate in. So a lot of you may be now checking about school ranking and then finding out which programs, which module is easy or difficult because you want to score good marks. And also you want to join a research program because hopefully it has a lot of market values. So these are some common questions that any prospective students will have to answer. But looking back, I actually want to share some of my personal experience in this. I want to, when you're choosing a school, I hope you don't just go for school ranking, but go to a place with a lot of role models. Because school rankings stay with the school, but the role models can influence you for the rest of your life. So make sure you pick a school with a lot of role models that you can learn from. And also, instead of focusing on marks when you join, I hope you will focus on building fond memories of the experience in the PhD program. Because again, marks, the value of marks actually vanish exponentially with time, but the memories actually increase in values as you become old. And also, when you are picking a research program, don't just go for the hot area or area with a lot of market values, because not all research programs with market values are meaningful. But most meaningful research programs to have some market value. So go for, hopefully when you join your PhD, you'll be able to find something which is both marketable and also meaningful. Now, talking about meaningful research program, I want to use the next few minutes to introduce to you this area of operation research and analytics, a field that I have been very passionate about. Now, what is operation research? In a nutshell, you can view OR as a body of language that uses powerful mathematical theories on real-life applied problems. So I use the story of Leonhard Euler, one of my idols in mathematics when I was a student. Now, Euler was a very prolific mathematician, but in the course of his career, he actually developed a body of knowledge which is very powerful. He was living in this city of Königsberg, and as a pastime in the city, there was this problem that the residents in the city likes to engage in because this is basically a game that the residents was trying to compete to fulfill. The goal was to walk across all the 7 bridges. You can see bridges linking the different islands in the city together. And residents were trying to walk across all of the 7 bridges, crossing the islands only once without ever repeating a single bridge in the course of one's walk. So there were a lot of attempts to do this and all failed miserably. So somebody went to Euler to look for a solution to these problems. And in the course of trying to solve this problem, Euler essentially developed the theory of graph. So essentially, Euler took applied problems, as in this case, strip away all the unnecessary details and focus on the essential, the nodes and the edges, and develop a body of mathematics to analyze the properties of this kind of structure, which he called graph theory. So this gives rise to the beautiful theory in graphs. And in fact, you can see that this process of taking a very applied problem, throwing away all the necessary complications, focusing on the essential, and developing math to perform the trade-off and to do the calculus is essentially the gist of modern-day operation research. Now, of course, this problem becomes known in the field as Eulerian graph theory, but this remains a very pure mathematical concept until the 60s, when Kwame from China essentially showed the world how this body of pure math can be used to solve some very applied real-life problem. In the Postman problem, so the Kwame was trying to solve for the Chinese post office this problem about designing the routes for the postman. So a postman has to deliver letters to a given neighborhood. So the challenge is to walk through all the streets in the neighborhood and back to the post office. So the question is, how can he design his route so that he walks the shortest distance? And essentially, in the 60s, Kwame presented this paper on using the pure graph theory devised by Euler to solve this particular problem that become known as the Chinese postman problem. Now, of course, I wanted to touch on this piece of history in operation research, in part because the Chinese postman problem has been used in many other applied problems, including our Singapore Armed Forces. In fact, there's the OR consulting firm IDSC in one of its project with the military, essentially use this concept to devise a solution for the Singapore Armed Forces in its cross-docking operations. So essentially, the military was looking for solutions to solve this very important problem about ammo storage and exchange. So there was a cross-dock that the military was operating, and containers with pre-configured ammo storage in the supply depot must be brought to the cross-dock center sorted and exchanged into new configuration to meet the needs of the evolving better planes. So this problem was outstanding for a few years because it was a very tough problem. IDSC undertook this consulting and essentially applied the theory of Eulerian graph to develop routes for these cross-dock operations, and essentially the system was adopted and is currently running in the military depot. I wanted to mention this because this solution was actually devised by another legend from the Department of Mathematics, C.C. Chen, who after retiring from NUS and in between his Qigong and golf, he actually developed this solution for IDSC. So there is nice applications in the context of Singapore for this body of knowledge. But mind you, this was actually done a number of years ago. And in the last couple of years, I think the field of operation research has gone through tremendous changes. And the most important question these days in the field of OR is to integrate the mathematical theories that pioneers have developed with data science, which is an emerging hot topic, to apply on real-life applied problems. And this gives rise to the field of operation research and analytics. Now, if you look carefully at the gist of most OR problems, it is about finding better solutions to existing systems. And finding optimal solution used to be good to have in the past, but in the age of analytics, you'll find that finding good solution becomes, or optimal solution becomes indispensable, because the scale of the problems have actually exploded. I show you here this, not the old traditional warehouse, but a modern automated warehouse where robots roaming around, delivering parcels, goods from the storage to the sorting area. And of course, behind every robot making moves in this automated warehouse is actually an OR and analytics algo predicting the future demand, future routes, predicting congestions, finding the shortest path to do the delivery. And of course, you can see that getting humans to devise solutions to this complex problem is no longer possible. Of course, this is body of knowledge is not used only in the warehouse. It also touches our daily life. Companies like TT or even Grab in Singapore are using the tools of operation research and analytics to do matching. So matching the passengers, the demand to empty cars roaming around the city. And of course, behind every matching solution that you devise, there are trade-offs, complex trade-offs in terms of revenue, in terms of service quality, in terms of safety, in terms of experience for the customer, so on and so forth. So this again, in problem of this scale, you'll find that OR and analytics tools becomes indispensable. Now, there are, of course, other than important applications in the industry, I think there are also very important fundamental questions that the field of OR and analytics will have to address in the coming years. In the attempt to integrate mathematical theories with data science, you'll find that there are a lot of interesting and challenging theoretical issues. If you look carefully, a lot of the existing theories are still about using the tools in machine learning, AI, to do a better job in descriptive or predictive analytics, and use the predictive model as input to the OR model to do the prescription, which we call the prescriptive analytics. But of course, if you look carefully in this is when you are dealing with prescriptive problems, making decisions out of data, you have to worry about whether the data is telling you the status quo or the new state after you have implemented your prescriptive solutions. So whatever you do, your prescription may change the state of the world, make rendering the past data irrelevant for the new world. So how do you integrate the data with your decision becomes one of the most pressing problems in the field of OR and analytics. And in fact, there are two key research questions that people in this field cares about. First is about finding out the model that best describes the data. So instead of taking the data as a black box to do the prediction, there's a fundamental questions in uncovering the best model to describe the data, so that you know that how the data is being generated based on existing state of the world. And then based on the understanding of how the state of the world changes, the best model to describe the data, the next challenge is to find the solutions, better solutions to solve the original problem. So you see a very rich source of problems to drive many OR and analytics research in the field these days. Now, let me talk about this to understand the importance of integrating data with decisions. Let me share this case on Singapore Pools. In October 7, 2014, Singapore Pools actually did something unimaginable from the product design perspective. So they actually changed the way they play the Toto game. In the sense, they actually make the games harder to win, more expensive, and essentially they try to make the product more inferior to the existing products. So instead of picking 6 number out of 645 to win the grand jackpot, now the punters will have to pick a set of 6 numbers from 49. So the odds of winnings becomes even much smaller. Now, so in any design, no matter how you look at the data on demand, you will find that this is an inferior product. But lo and behold, with this implementation, you can see, I show you here the sales generated by this game after the change in the game design. So with this simple game design change, basically the sales of the total game actually jumped by about 100 million per year. And the way to see this actually has to come from detailed understanding of how punters respond to the prices. So if you were to just blindly focus on existing data, you will not be able to arrive at this new design in the games. So there are plenty of such stories around that. I hope after you join the institute, you will get to learn about some of these stories and theories, and hopefully along the process, you will also generate your own stories and create histories in the field. So in the institute, there are students and faculty members are basically applying these tools and body of knowledge on various classes of problems. So not just the cross-dock center in the military depot. You see this body of knowledge being applied in our port, the PSA, and in terms of berth planning. You see also this body of work being adopted and implemented in the air cargo terminal standard assignment. I talk about the matching drivers to passenger stories and various other stories. So essentially, there's right now a group of very active scholars in NUS now working to modernize the field of operation research through integration with data engineering and science. So I hope you can join us in one of these pursuits. Now, so 4 years ago, we actually, because of the promise in this particular area, a group of faculty members actually put together a proposal to set up this Institute of Operation Research and Analytics, drawing strength from across the campus. You see the business school, the IE department, the CE department, the TLIAP, the Com Science, the Econs group. We do have many people working in the field of OR and analytics. And in recent years, we have also brought in many young talented new and senior professors into the NUS. So you see faculty joining us from all over the world, and many young faculty members joining us. So if you're looking for role models, I want to assure you that many of my colleagues shown on this picture will be a good role model for you. If you're looking for fond memories, I want to also assure you that we have rather well-established multidisciplinary PhD programs in the field of OR and analytics for us to develop joint memories. So with this, I want to end my talk to give you I gave you a quick introduction on the field of operation research and analytics. And to find out more, you can go to our website to look at the latest development. Yeah, I think I can end here. Thank you.
Thank you very much, Professor Teo. I think there is one question so far. The question is, can you shed some light on the kind of research problems in healthcare that the NUS IRA is working on?
Okay, so I have a few faculty members working in the area of healthcare analytics. So they are works in the area of resource allocation, resource optimization in hospitals. But we are also starting new areas in the health insurance analytics. Essentially, there's working on a new projects on trying to understand the spending behavior in, for example, in integrated shield plans in Singapore, how the insurance plan can be redesigned to nudge patients to spend in the correct manner so that we can collectively reduce the health insurance expenditures. So there are various projects pioneered by different, spearheaded by different faculty members in these directions.
Yeah. Okay, thank you. Another question is, what kind of research problems are worked on interdisciplinary or combination of business OR, and data science? Can I get some understanding of this, please?
One example, of course, my colleagues will tell you, will answer this in a slightly different way, because there are essentially many directions whereby you can combine area in business and OR and data science together. One of the big problems in this modern environment now is food safety or supply chain resilience. So supply chain resilience is a problem that I think most companies will have to address post-COVID. And of course, when you look at supply chain resilience, now there are tons of OR and analytics issues. The predictive side is about getting the features that allow you, that will give you advance warning to potential disruption affecting your supply chain. The prescriptive side will have inventory pre-positioning or capacity buffering that you can adopt to cushion your supply chain from all this potential disruption. There's also a more strategic level of research that talks about flexibility and about making your process more resilient to disruption. So the ability to operate in a flexible manners can in fact affect the supply chain resilience of many companies. So there's a lot of opportunities for multidisciplinary research in this particular space.
Okay, very good. There are two questions that are very similar regarding how quantitative does the background of the candidates for PhD needs to be in order to apply. That means, do they require high math background?
Okay, I must, in terms of the background, I think you must appreciate quantitative reasoning. So you don't have to know very bombastic math in order to make a serious contribution in the field of OR analytics. But you must appreciate the use of evidence-based decision making. So you must appreciate the role of data in making decisions. So you can actually make data dance and reveal itself in many different ways, and you don't need a very deep level of mathematics to appreciate this area. But of course, knowing mathematics will give, advanced mathematics will give you a more powerful tools to answer some of the questions in this particular area. But you don't need to know them.
Okay, there's another question. Do all PhD students get to participate in the Institute industry research projects?
Okay, so the institute, let me answer also the other questions about the number of PhDs.
You're right.
So we have, we take in about 5 to 7 PhD per year, but in the next 1 to 2 years, we are actually expanding our intake because we have these MOE Tier 3 projects that allow us to take in slightly more PhD students. So over the next couple of years, there will be an expansion in the PhD intakes into the PhD program. But for students who come to the PhD program, in the institute, we actually don't force the students to do industrial research. We want them to do industry research, but we also see the danger of forcing students to do a piece of research when they first join the institute. So basically, we allow the students to develop their own research agenda, but along the way, when the professors has industry projects, they will come to the institute to talk to students, to get them interested to work on the industry projects so that funding can be provided to the students subsequently. But we don't force or matchmake students to specific industry projects. So you can view the institute as a platform like the TT platform. Faculty members will bring the projects into the institutes. Students who join the institutes will sort of evaluate the projects and see which one they are interested to work on. Yeah. But a number of the PhD students are working on advancing the theory of mathematical optimizations. So we have people doing research in different areas.
Okay, I think any more other questions? Does a MSc student join a research project under IRA? I think it's same.
So we do get we don't run MSc program, but we do have MSc students working on research project, but those are mainly industry driven projects. So we engage the MSc students normally as research assistant for the industry projects.
Okay, and then I think the TOEFL question we can answer offline. How do you determine the purpose of research, which could be 4 years down the line? I think the practicality of the research post PhD.
Yeah, the purpose for research. I think this is a question that all PhD students must address. You must find a purpose in research, and I will not be able to answer these questions for you, but I think what we can provide is an environment and some role models and support for you to find the answer yourself over the next 4 years.
Yeah. Okay, thank you very much, Professor Teo. As Professor Teo uses math to solve practical problems, I think the next speaker will be talking more about math too.